Hello everyone and welcome to class. Today we'll be dealing with our first week's topic for SS3 scheme of work, which is Surds. Now, prior to this video, I will be releasing a video that defines and give examples of the different kinds of numbers that we have. So we don't go into details talking about rational and irrational numbers. Very quickly, what are surds? Now, surds are the square roots of non-perfect squares. Now, in the video I'll be releasing prior to this, we would be dealing with the definition of perfect squares. So by the time you watch that video, you would have no problem giving definition towards non-perfect squares. Now, non-perfect squares such as 7, for example, 9 actually is a perfect square. Now, make sure you watch that video. It will help you develop some foundation in your mathematics. 7 is not a perfect square. 9 is a perfect square because the square root of 9 would give us what? 3. 4 is a perfect square because the square root of 4 will give us what? 2. What number do we have now? We have 81. 81 is a perfect square because the square root of 81 will give us what? 9. But 7 is not a perfect square because its answer would give us a whole number with decimals, which will be an irrational number actually. To give us an irrational number. So surds are the square root of numbers like this. There's a way we solve numbers like this. I will also be giving description to a chart I would love you to create in this same video. We will be creating a very simple chart. In the video I did in our indices class for SS1, there was a chart I created. That one was for the index value of different numbers from 2 upwards. But what we'll be doing now is to find the squares of different numbers from 2 upwards. So we'll do that probably for 2 to 15. So we just write 2 square is what? 4. 3 square is what? 9. 4 square is what? 16. 5 square is what? 25. 6 square is what? 36. 7 square is what? 49. 8 square is what? 64. 9 square will give us 81. 10 square should give us 100. 11 square should give us 121. 12 square should give us 144. 13 square should give us 169. You can do it till as many as you can. But I think this should be safe enough for us to solve most of our questions on surds. So make sure you have this written down somewhere. Now, all this is to make learning more efficient for us. We can decide to stress ourselves over and over every single time we are solving questions. But when you have this beside you as you solve your questions, it makes your learning quite easy. Now, we would be going straight to our laws in surds. We are calling laws now. Yes, the way we operate in surds. Now, very quickly, do addition of surds. Now, addition and subtraction work the same way. When you have something like this, are you following me? You cannot add them together. They give you the same value. That is, if what is in this surd value and this surd value here are different numbers, they cannot add up. But when you have something like this, are you following me? Now, this will give us 2 root a. For example, you have root 7 plus root 7. It will give us what? 2 root 7. You have root 9 plus root 9 to give us what? 2 root 9. Now, if you have something like 5 root 3, sorry, not root 9 now. You have root 19. because 9 is actually what? A perfect square. Now you have 5 root 3 minus root 3. It actually gives us 4 root 3. 7 root 11 plus 4 root 11. They give us what? 11 root 11. Now this one has an invisible coefficient of 1 behind it. Always make sure you take note of these operations. So the way addition works for surd is also the same way subtraction works for surd. If they don't have the same value in the surd, they don't have the same surd value, they cannot be added together and they cannot be also what? Subtracted from each other. Before I would go into breaking down surds, let's deal with the multiplication and division of surds. Now, when you have root A, so that is surd A times surd B here, is actually equals to what? This. Now, in the same way, if you have, in the same thing as saying what? Take note of this. This is very, very important. This is very, very important. And I would love to inform you also that these laws can be used in reverse. They can be used in reverse. So if you have root 3 times root 3 is actually what? Root 3 times 3 equals to root 9, which actually gives us what? 3. Now, if you have something like this, root 27 actually gives us what? Right? Yes. Now, looking at this, if you take this law in reverse, that is from here, work it to this place, then reverse it like this, what you will have will now be root 3 times root 9. Now, you can find root 9, you cannot find root 3. You now have what? 3, which is root 9, Abi, times root 3, which is what? 3 root 3. And by the way, take note also, if you have a whole number multiplying a surd, it actually gives you this. Take notes. If you have your own number multiplying your surd, it actually gives you this. Before I would go into breaking down surds, let's deal with the multiplication and division of surds. Now, when you have root A, so that is surd A times surd B here, is actually equals to what? This. Now, in the same way, if you have, in the same thing as saying what? Take note of this. This is very, very important. This is very, very important. And I would love to inform you also that these laws can be used in reverse. They can be used in reverse. So if you have root 3 times root 3 is actually what? Root 3 times 3 equals to root 9, which actually gives us what? 3. Now, if you have something like this, root 27 actually gives us what? Right? Yes. Now, looking at this, if you take this law in reverse, that is from here, work it to this place, then reverse it like this, what you will have will now be root 3 times root 9. Now, you can find root 9, you cannot find root 3. You now have what? 3, which is root 9, Abi, times root 3, which is what? 3 root 3. And by the way, take note also, if you have a whole number multiplying a surd, it actually gives you this. Take notes. If you have your own number multiplying your surd, it actually gives you this. Now, indices has a streak, logarithm has a streak, and surd also has its own trick. Probably that's why they are grouped together. The main challenge in solved questions sometimes might not even be factorizing. The main challenge most times is when you have questions like this, which will always occur, minus root 3. Now, according to the principle I just taught you, in adding sorts together, this should not be able to add each other. So what do we do here? What do we do here? We will convert this one in a way. Now, remember that I just told you now that when you have this, you can convert it to look like something with root 3 so that you can now apply the law of addition to add these sorts together. Having that chart I just told you to create that contains the squares of numbers makes it easier for you to do what? To solve questions like this. So you have root 27 now can be replaced to the what? I just told you can use these laws in reverse, right? And so you have root 27 to be what? 9 times 3. And so it will be equal to what? We split this up, right? You have 9 times 3. Now, the square root of 9 being 3, we multiply it by root 3. We now have what? 3 root 3. Just follow through the class, you will get it clear. 3 root 3. Now, if you replace this 27 with 3 root 3, they are actually the same thing. Now, if you replace this thing here now, you will be getting 3 root 3 minus root 3. Now, if you follow the law of addition, what we just do, we get what? 2 root 3 as our final answer. The main challenge most times is getting to break down questions like this into having common sorts. That is why that chart makes your work and your learning quite easy. When you use that chart for a while, you get used to it. Even without the chart, you will be able to work. You'll be able to solve questions on sorts. We will be going to rationalization of sorts. This is also very simple. Rationalization of sorts. Okay. Now, when you have a value like this, 2 over root 2. Actually, root 2 is also a sort because the square root of 2 gives us an irrational number. Make sure you watch that video that describes the types of numbers. Okay, now we are not supposed to have a final answer like this in sorts. So when you are solving solve questions and you end up getting answers like this, you do what you call rationalization of sorts. You rationalize your sorts. How do you rationalize a sort like this? Or you rationalize something like this? What do? You multiply it by this, which is in the denominator. Root 2 over root 2. Which will now give us what? 2 root 2 over what? Now, apply the law of multiplication of what? Of sorts. We do this 2 times 2, right? Root 4. Which will now be what? 2 root 2 over 2. 2 can cancel 2. Take note. Which will now be what? Root 2 as our final answer. Now, that is our answer after rationalizing the sorts. Make sure that you don't have any sorts in your denominators. When you are solving any question on sorts, none of your denominators must be a sort. Whether if it's single like this or if it's an expression like this. Let's say 3 over 2 minus root 5. 3 over 2 minus root 5. For questions like this, or for denominators like this, you find the conjugate. Now, for 2 minus root 5, the conjugate would actually be what? 2 plus root 5. 2 plus root 5 is the conjugate for 2 minus root 5. Take note. 3 plus root 2, the conjugate will be what? 3 minus root 2. So that's the conjugate. Now, finding the conjugate of this, you have what? 2 plus root 5, right? You multiply both the numerator and the denominator by the conjugate of the denominator to rationalize this kind of surd expression. Now you have this 2 plus root 5 over 2 plus root 5, which will give us what? You multiply this by this, multiply this by this. You have 3 open bracket 2 plus root 5 over 2 minus root 5, 2 plus root 5. So we begin to expand, right? We now have what? 3 times 2, 6. 3 times root 5 will give us what? Plus, take note, 3 root 5 over, expand this. You can use this one to expand this one or vice versa. It works either way. You have 2 open brackets 2 plus root 5 minus root 5 open bracket 2 plus root 5. Now we'll have what? 6 plus 3 root 5 over 2 times 2 gives us what? 4. 2 times root 5 gives us what? Plus 2 root 5 minus, take note. Now minus 5 times 2 would actually give us what? Minus 2 root 5. Minus times plus will give us what? Minus. Now root 5 times root 5 will give us what? Root 5 times 5. Now you have what? 6 plus 3 root 5 over, take note, plus 2 root 5 minus 2 root 5 will give us what? 0. So you have 4 minus, because this is equal to 0 already, 5 times 5 is what? 25. Now root 25 will give us what? 5. So you have 6 plus 3 root 5 over 4 minus 5 will give us what? 1. Our answer is what? 6 plus 3 root 5. Make sure you join the Telegram group so that you can get the questions we will be releasing as exercises. And when you have tricky or challenging questions, you can always post them also so that we can make progress together. Of course, you know, I'm sure you know that we cannot solve all the possible questions under Surds in this class. Very quickly, let's solve the first question. Now, look at 48, 75, and 12. Obviously, if you add them normally according to the law of addition of Surds, you will discover that they cannot be added together. Now, the next question we should be asking now is there a way to make all three of them have the same Surd value? The answer is yes. That's where your chart comes to play. Now, most times they will have these numbers that are Surds would have a common non-perfect square as a common factor and a perfect square also as a factor of each one of them. For example, looking at this, you discover that 48 is what? 3 times 16. 75 is what? 3 times 25. And 12 is what? 3 times 4. These other 3 here are what? Perfect squares. And these other 3 here and this one, they are what? They have the same value. And this one, because they are not perfect squares, this one will end up being the Surd value that we can now work with. The main challenge in Surd problems is actually this, then factorization. Surd problems are actually not that tricky. Okay, now if you apply this, you will discover that what? Root 48 would actually give us what? Root 3 times what? 16, which is what? Root 16 times root 3, right? Now root 16 is what? 4. 4 times root 3 will give us what? 4 root 3. Root 75 is actually what? 3 times 25. Now, root 25 times root 3. Of course, you know we are reversing the law of multiplication here, right? Okay. Now, root 25 times root 3. Root 25 being what? 5. 5 times 3 will give us what? 5 root 3. Then you have what? Root 12. Root 12 is what? Root 3 times 4. Now, root 4 times root 3 is actually what? Root of 4 being 2 times 3 will give us what? 2 root 3. Replace this here now. You have what? 3 root 48 minus root 75 plus 2 root 12 would actually give us what? Now, this 3 is outside, Abi. You write it like this, times what? 40 root 48 here now, because this is, this here is actually what? 3 times root 48, right? Now, root 48 has been replaced with what? 4 root 3. You put it there, 4 root 3 minus root 75 here has been replaced with what? 5 root 3. Notice that there is no value at the back, so we can just write 5 root 3 straight away. Plus 2 times what? Root 12 being what now? 2 root 3. Now, solving this is actually not hard. 3 will only multiply 4. It will not multiply root 3. Take note. So 3 times 4 is what? 12 root 3 minus 5 root 3 plus 4 root 3. This gives us what? 12 root 3 minus 5 root 3 would actually give us what? Now 12 minus 5 is what? 7. 7 plus 4. 7 root 3 plus 4 root 3, which actually equals to what? 7 plus 4 is what? 11 root 3. This is our answer for number 1. Very quickly, we'll solve the second question. Now, if 2 root 3 plus 3 root 2 over 2 root 3 minus 3 root 2. Now there's nothing to solve much here. All you have to just do is what? Rationalize. So you do what? Rationalize. I just thought of that to rationalize this, we take the conjugate of the denominator. We are not interested in the numerator. We are not interested in what? Denominator. This question has nothing to solve. So we just go straight to rationalizing. Okay, when you rationalize, you have what? 2 root 3 plus 3 root 2 over 2 root 3 minus 3 root 2 times the conjugate of this is what? 2 root 3 plus 3 root 2 over 2 root 3 plus 3 root 2. Remember I said we multiply the numerator and the denominator by the same thing to rationalize this. Okay. Now, you begin to multiply. We take this one to multiply this one. You have 2 root 3, open brackets, 2 root 3 plus 3 root 2 plus 3 root 2, open brackets, 2 root 3 plus 3 root 2 over 2 root 3. You are taking this one now to expand this one. 2 root 3 plus 3 root 2 minus 3 root 2. Take note to 2 root 3 plus 3 root 2. Now, we're expanding. We'll have what? This time this will give us what? Now, when you multiply something like this, whole number will multiply whole number, sod will multiply sod. You have what? 2 root what? 2 root 9. Why is it root 9? Root 3 times root 3. 2 times 2. Sorry, this will give us 4 instead. 4 root 9 plus 2 root 3 times 3 root 2 now. We give us what? 2 times 3 is what? 6. Root 3 times root 2 give us what? Root 6. Now, plus what? 3 times 2 is what? 6. Root 2 times root 3 will give us what? Root 6. Plus 3 root 2 times 3 root 2. 3 times 3 will give us what? 9. Root 2 times root 2 will give us what? Root 4. Obviously, we'll still find the square root of these two numbers. Now, the over what? This will give us what? 4 root 9 plus what? 6 root 6 minus 6 root 6 minus, because plus times minus is what? Minus 3 root 2 times 3 root 2 will still give us the same thing as what? 9 root 4. Now, don't forget the cell is what? In the form of n plus n root 6, right? And we are breaking it down already. Now, root 9 is what? 3. 3 times 4. Look at that. 4 root 9 is what? 4 times root 9, right? So, root 9, which is 3 now, times 4 is what? 12. Plus what? 6 root 6 plus 6 root 6. Now, they have the same value inside, right? They have the same surds. So, 6 plus 6 will give us what? 12 root 6 plus 9 times 4. No, sorry, 9 times 2, which is root 4, abi? 9 times 2 is what? 18 over, this will also give us 12. This minus this we cancel out, right? Yes. We now have what? Minus what? 18. So we have equals to what? 12 plus 18 will give us what? 12 plus 18 will give us 30. 30 plus 12 root 6 over what? 12 minus 18. 12 minus 18 will give us minus 6. Now, we can actually factorize what is here. We factorize what is here, we get what? 6 can actually go in 30 and 12. So you have 6, open bracket, 6 in 30 is what? 5 plus what? 2 root 6. Take note of what I just did here. 2 root 6 over minus 6. So this cancels each other and this is minus 1. So this divided by minus 1 will give us what? Minus 5. Now, when you expand the bracket, now be minus 5 minus 2 root 6. Minus 5 minus 2 root 6. So, comparing this with m plus n, our m will now be equals to what? Minus 5. Because m is the one that is an ordinary number, while n is the one that is standing with what? Root 6. So, n will now be what? Minus 6. And that's our answer for this question.